So last day we learned about a couple of things. First thing we learned about EMF. And we said that, for example, if a battery has a 2-volt EMF, it means that for every coulomb that leaves it, it gives it 2 joules. If it has a 4-volt EMF, like this one, then for every coulomb that leaves it, it gives it 4 joules. And we also saw that when the coulombs go through the light bulb, they need to leave part of the energy. So if the PD is 4 volts, this means that the coulombs are going to leave 4 joules that they were carrying here, and then they will arrive here with no energy. We also saw that our coulombs need to have left all the energy that they have before they arrive back to the battery. So we can express this mathematically as simply stating, well, if this is 4 volts and I have, I don't know, let's say 3 coulombs, since each coulomb gets 4 joules, then in total I will get 3 coulombs times 4 joules, that's 12 joules. So the energy that charges get in general is just the charge that I have, so for example 4 coulombs times the potential difference. That tells us how many joules per coulomb I'm giving these things. We also talked about current, which just says how many coulombs per second are going here. So if I stay here and I see that there's 8 coulombs going through in 2 seconds, that means that every second there's 4 coming through. So what did I do in my head? All I did was divide 8 coulombs between 2 seconds, and then I get 4 coulombs per second. And remember that the units for intensity, and remember that this means unit are amperes, and remember that 1 ampere is a coulomb per second. Now I know that we've been calling this thing here EMF, because this is really the energy that a battery gives a certain electron. From now on I'm going to be calling this PD. Now what's the difference between this PD here and this PD here? And the difference is that in this case, between here and here, my coulombs have gained energy because they've been given energy by this EMF here, by the battery. Whereas in this PD, my coulombs are losing energy. So this is really a potential drop, whereas this is a potential increase. So my coulombs go from here to here, they gain energy, and then once they go through here, they lose their energy. Once they go back through the battery, then they gain back the energy, and so on and so on. So what really happens is that the battery creates a potential difference between here and here, so that the electrons actually gain energy as they go through it. Okay, now that said, we're going to talk about something called a resistance. And the idea of a resistance is that it's a piece of circuit that doesn't let electrons go through. I mean, it does let them go through, it just makes it very, very hard for them to go through. And what this causes is a decrease of the current, because it's so hard for these guys to move that of course there's less coulombs being emitted from this battery each time. The more resistance, the harder it is for them to go through, the less coulombs I'm going to have. However, the more PD that I have being supplied by this battery, the more coulombs that I'm gonna have, because of course they're getting a lot of energy and they're getting pushed a lot. So again, this pushes my coulombs to go through the circuit, so it increases my current. This makes it hard for them to travel through the circuit, so it decreases my current. Let's see if we can turn this into an equation. Alright, so I asked myself, how can I find the current, I, if I know the PD and I know the resistance? And as I said before, when the PD is very big, then the current gets bigger. So this tells me that the PD should be multiplying. So okay, so let's just put it here, so PD. And then when the resistance is very big, then the current gets smaller. So this tells me that it should be dividing. And that's how I can find the current if I know how much resistance this thing has, and I know the PD supplied by the battery. However, we still haven't talked about how to measure resistance or what resistance is. But actually, this equation here is the equation that defines resistance. So I'm going to turn it around. I'm going to put the R here and the current here. Remember that this is an equation. If I multiply both sides by R, then there's an R here and this disappears. Then if I divide both sides by I, then the I disappears here and then the I goes over here. Okay, so I have that the resistance is the PD over the current. And this is exactly the same equation that I just wrote. I just rearranged it. Now, how do I measure a resistance? Well, very easy. I take a circuit and I measure the PD between here and here. Now, like, okay, using a voltmeter. And I don't know if you remember this from last year, but a voltmeter is a piece of equipment that allows me to determine the potential difference between two sides. And I need to plug it in like this, so that the current actually keeps going through this. So this is like a little probe. It tells me the current between here and here. And then I connect an ammeter, for example, here, and the ammeter will tell me the current going through here. And if I know the current going through here, then I will know both this and this. And then if I divide them, I will get the resistance. Now, what are the units of resistance? Well, remember this means units, so units of resistance, and we will do the same thing that we did the other day. We figured what the units of these are, we figure what the units of these are, and this will be the units of resistance. So the units of PD are volts, and the units of current are amperes, so volts over ampere. But again, I'm too lazy to actually write this all the time, so I call this ohm, which is this kind of horseshoe shape. And second, the way to write this is ohm. So the units for resistance are ohms, which are just a shorthand for volts divided by amperes. And that's really the main things that we need to know for today. It's just that the more PD, the more current, the more resistance, the less current, and we can calculate resistance if we figure out the PD and the current at a certain point in the circuit, and then we just divide them and we get the resistance, and the units are ohms. Now we just need to do one last thing before we finish the video, and talk about the factors that affect resistance, especially in a conductor. Remember that a conductor is just a cable of a metal, things like that lets an electron through. But every conductor, anyway, has a certain resistance. And this thing that we're going to talk about now doesn't really work for some other kinds of materials, because these other kinds of materials, the resistance depends on a lot of other things and a lot of really weird exotic factors. So the idea is I have a conductor, and then I ask myself, well, what things could possibly affect the resistance of my conductor? Well, the first thing that I can think of is the length, right? So if I make this longer, then my coulombs will take longer to go through, and therefore it will be harder for them to get through. It's like if I have a rainforest that measures 2 meters, it's pretty easy to get through it. But if I have a rainforest that measures 2 kilometers, then I'm going to spend a while going through the rainforest. So in the same way, the longer the resistance, the more resistance you have. So if I have two cables made of the same material with the same width, and one is longer than the other, then the longer cable will have more resistance. In fact, we can say that the resistance is proportional, and this letter here means proportional, to the length. What does that mean? Well, that if I double the length, so if I go from length to twice the length, then my resistance would also double. It also means that if instead I decrease the length, so I go from one length to, let's say, 1/3 of the length, then my resistance will also become 1/3 of what I had. And that's all there is to it. However, there's another factor that affects resistance, and that's the area. The idea is that if I have a very wide area, there's many ways for the coulombs to travel around my cable. So I'm actually making it easier for coulombs to get through. Therefore, having a bigger area actually decreases resistance. So that resistance is really proportional, not to the area, but to 1 over the area. And what does this mean? Well, this means that basically the more area, the less resistance. The less area, the more resistance. So let's see what this means. So imagine that I have this thing here, and I make the area to be half. So I take my area, and now I have half of the area. Well, since I've divided this by 2, my resistance will get actually bigger. And how much bigger? Well, twice as big. Because the resistance is proportional to the inverse of the area. So The more area, the less resistance. The less area, the more resistance. So the resistance will go to 2R. What if instead I double the area? So my area goes to twice the area. What will happen to my resistance? Well, my resistance then will be less. How much less? Well, half. Now, this is a little tricky because we're talking about the area. And sometimes they will actually tell you about the diameter. And remember that the diameter is not the area. The diameter is a length, and the area is an area. What you need to remember is that instead of, maybe it will make it easier if you think about a square instead of thinking about a circle. If you have a square of side A, and I double this side, well, I double both sides, what will happen is that the area of the square is going to quadruple, right? So the area of this square is A squared. But if I make this side 2A, so 2A and 2A, then the area becomes 2A squared, which is 4A squared, which is 4 times as much as this one, not twice as much. So remember then that when I have a diameter and I make the diameter twice as big, it's just like making this thing twice as big. Then the area is going to quadruple, not double. So bear this in mind while you're doing the problems, or you will get the wrong answer most of the time. Alright, so that's it for today. Now, to see if you're on track, first thing, can you define and calculate resistance? So to define it, just remember, it's just the PD over the current, and to calculate it, it's just the PD over the current. So both things are pretty similar. Now remember that the units of resistance are ohms, which are really volts over ampere. Now, remember that we can calculate the current from the PD and the resistance. So the more PD, the more current, the more resistance, the less current. And finally, are you capable of figuring out how length and area will affect resistance? So remember that when we increase the length, then the resistance increases. When we increase the area, then the resistance decreases. And if you know how to do this, you should be fine for the problems next day. Good luck.